That's fine. We're doing acceleration. So lesson 31, acceleration. And what we started last time was talking about this idea here as displacement time graph. Thanks for helping me out, Brendan, by the way. As someone else probably said in the chat too. As time goes forward, the displacement changes. We can see that in a graph, and this tells us a lot of information about how it's moving, even though, and this is like, I guess, the advantage of this, right? Even though we don't know where it is at 1.5 seconds, because we've got a line, we can actually look that up and figure out, oh, it must be this much, it must be whatever. So after we talked about that, we moved on to discussing displacement time graphs. We talked about if the gradient's really steep, we say that moving fast because its displacement's changing quickly. If the steep is really, if the gradient's really shallow, then we say it's slow. And that gradient is also the velocity. It's the speed it's changing over time. Then what we did was we talked about here. This is what I'm talking about. So this is gradient of displacement time graph. We measured the gradient, but I want to show you guys something new. Let's go and look at this. What happens at 15 seconds? At 15 seconds, if I went up, I could tell you that at 15 seconds, that person is about 13 meters away. Now that's not one of the dots. And I could actually then say, oh, at what time did they get to 5 meters? Well, I would go across. At 5 meters, they get to 5 meters away in about 43 seconds or so. So being able to read a graph like this is also going to be pretty useful, not just being able to measure velocity. So I probably should have put that on that slide, but I guess you guys have just learned that now. Then we talked about, we did an example where we had a mouse that was moving away, moving up to some cheese, eating some cheese, moving back, and then quickly running back home. And we talked about how that speed changes over time and when was they moving the fastest and when was they moving the slowest. We did another example. We finished up on velocity time graphs, which is not about, which just talks about how speed changes. So this one is like this flat line doesn't mean that they're stopped like it does in the displacement time graph. It means that they're moving forward at the same speed. And here means that they're moving backwards. And then we did some examples where we took these lines and we drew them. So today we're going to talk about acceleration. What is acceleration? Ladies and gents, this is, I did a little bit of research, this is a Tesla Roadster. Now the Tesla Roadster hasn't come out yet, but...
That's a Tesla?
Yeah.
I ain't no looking like no Tesla.
Yeah, I know. This
What the fuck is that?
This Tesla Roadster, this is the Tesla Roadster. It will be the fastest electric car in the world. It will go from 0 to 100 kilometers an hour, well, approximately 100 kilometers an hour, in 1.9 seconds. Now that's incredibly fast. That's faster than any car. I think it's faster than any car in the market at the moment. Like the fastest cars, like you can get from 0 to 100 kilometers an hour in like about 3 seconds, sometimes 6 seconds. A cheetah, by the way, if you want to know how fast a cheetah runs from 0 to 100 kilometers an hour in 3 seconds. So this is faster than a cheetah. Not only is it just faster than a cheetah, but it can get to that speed a lot quicker than a cheetah can. And you're like, okay, that's really, really quickly. That's really, really quick. So what I want to talk to you guys about is that's an amazing speed, but we have a question here is this, and this is the thing. This is an insane change in speed, but it does it so, and it does it so quickly. Like that change in speed is really, really quick. So how can we compare this change in speed for other cars or other moving objects? How can we talk about how quickly the speed changes? I want to be able to say, hey, I've got a Tesla Roadster. It can go from 0 to 100 kilometers an hour in 2 seconds. And then they can say, well, if their car doesn't go to 100 kilometers an hour, how can I compare the speed? It becomes a bit difficult. How is it fair? How can I, if I look at something like a rock that's been thrown, how does its speed compare? So we need a way to talk about how quickly speed changes. And luckily, we do have a way that we can write that down. That's what acceleration is. Now, acceleration is the rate at which velocity changes. It means speeding up or slowing down, or how fast something speeds up or slows down. I'd like you to write this down, by the way, ladies and gents. It's measured in meters per second, or meters per second squared. Why is it measured in that a weird thing? Well, think about it. If something's going 10 meters per second, that means that every second it gets 10 meters per second faster. So it goes 0 to 10 meters per second, to 20 meters per second, to 30 meters per second, to 40 meters per second, and so on. But if you've got something that's going 1 meter per second, well, that's going to go 1 meters per second, 2 meters per second, 3 meters per second. But yeah, if you don't understand very much about what's going on this page, you just have to understand acceleration means speeding up or slowing down. I'm going to give you a little bit longer to write this down. Okay. It's a vector quantity. What that means is that it has a direction. So when you talk about I'm accelerating, you can't just say I'm accelerating, you have to say I'm accelerating north, or I'm accelerating down the road, or something like that. And last but not least, we've got a formula here. It's the change in speed. So in order to do that, we need to have a final speed and an initial speed. So if I take the final speed, my final speed is 100 meters per second, and my initial speed was 0 meters per second because I was stopped, and I do that in 1.9 seconds, then that means my acceleration is, I'm going to work this out properly, 100 divided by
52.63.
Thank you. 52.63 meters per second squared. That's how fast. So that means that every second you can travel 52 meters per second faster. For the record, by the way, that's about 52 meters. Actually, sorry, that's not meters per second. Whoopsies, that's kilometers per second. Sorry about that. That's actually completely wrong. Ugh. Because I mixed up the units, right? 100 meters per second equals 100 kilometers. So let me try this again, because I actually completely stuffed that up. Thank you for helping, Brendan, but I stuffed that up really badly. 100 kilometers per hour is equal to 27.8 meters per second. So if I can go 27.8 divided by 1.9, that means I'm going 15 meters per second squared. That's the actual answer. There you go. Mr. Green made a mistake, so you guys can learn from that. What that means is that every second I'm going 15 meters per second faster. So and 15 meters per second, by the way, is about 50 kilometers an hour. So after 1 second, I'm traveling 50 kilometers an hour. After 2 seconds, I'm traveling 100 kilometers an hour. After 3 seconds, you're probably traveling 150 kilometers an hour. It's just going to be insane. This car, anyway. So that's what acceleration is. I'm going to change the slide now just to talk a bit about, this is the last slide that I'm going to talk about today. This lesson is this here. And there's a fair bit of text here, but I'm trying to keep it really small words here. And it's just like, what does acceleration do? When the acceleration is in the same direction as the velocity, your velocity will increase. In other words, you'll go faster. Okay? So I want you to write this top part down, and then I want you to write this top part down, and then what we're going to do is we're going to look at the car moving. Okay, so this is our little car here. And that little car is going to start off going at this speed, right? I mean, that was pretty fast. But then what we're going to do is we're going to hit that little car with an acceleration. Oops, that shouldn't have popped up. Oh well. Bam! That acceleration is going to make that car move faster. So when that acceleration comes, it's going to then make it move faster. So now it's going to speed off. The acceleration changes the speed of the car. Now, some important factors to look at here is notice how the arrows are in the same direction. Okay? That's because you are accelerating in the same direction that you are traveling in. So that means that your velocity will add. You add speed. So that's why at the end it goes faster. Okay? Now what we're going to do is we're going to look at the little car at the bottom. If the acceleration is in the opposite direction of your velocity, your speed will decrease. It'll do the opposite thing. You'll change your speed because that's what acceleration does. Acceleration changes your speed, but instead of changing your speed and making it go more, you'll change your speed and you'll make it go less. This is going slower. This is what happens when you put the brakes on in your car. You can even sometimes slow something down so much that it will start, you put such a negative acceleration on that it starts to go backwards. This is called deacceleration. So you've got acceleration when you go faster, and deacceleration is when you go slower, and it's a negative value. So I'm going to show you what that looks like. So remember, with the red car, as it moves, as we add acceleration, it makes that orange velocity line bigger, which means it moves faster. But with the blue car, when we add our velocity, see how it's pointing the opposite direction? It's pointing the opposite way. So your deacceleration, your acceleration is in the negative direction. That means that your velocity will decrease. Your speed will get smaller. And so this car is now going to move slower. That's the difference. So just so you know, acceleration means something speeding up or slowing down. If the acceleration is in the same direction that you're traveling, you speed up. If it's in the opposite direction, you will slow down.